Now that we've covered the basics of variable types, continuous variables, and categorical variables, let's think about how to put them together to answer a research question. Asking questions is the point of biostatistics. In fact, using biostatistics to answer questions with data is really the development or the crux of the field. Some questions that you might consider: is race related to blood pressure? Is age related to blood pressure? Do men and women have different blood pressures? Do BMI categories have a different percent of people with high blood pressure? So you can see in each of these questions there are two variables. In the first question, one variable is race, the other variable is blood pressure. In the next question, age is a variable, blood pressure is a variable. In the fourth question about BMI categories with a different percentage of people with high blood pressure, that's where you've taken the blood pressure value and created an indicator or a cutoff variable for high versus normal blood pressure. In general, you can see that the pattern of all of these questions is a predictor or X variable related to Y, the outcome? Is there a relationship between these two variables? So where do you start in writing questions? First, you have to define the relationship. And relationship is a very general term. Differences in means or medians. So the mean systolic blood pressure by gender, or the median weight by race. Or the difference in proportions, the percent with high blood pressure by gender, or the percent obese by race. Or, more simply, associations between two continuous variables. Is higher weight correlated with higher systolic blood pressure? Is older age correlated with higher systolic blood pressure? So again, you see the pattern starting with two variables, with a predictor and an outcome. Start with those two things. Define your outcome variable and your predictor variable. So once you've identified those two variables, you have gone very far towards leading you to the analysis that you'll need to do to determine if there is a relationship between those variables. So let's talk a little bit more about the outcome. You need to pick an outcome when you define your question. So we know we need a predictor and an outcome. The outcome is what you are wanting to measure. Is there a change in systolic blood pressure? Do people lose weight? Do people improve their lung volume? The outcome variable is what you want to know. If your research is in cystic fibrosis, you may be wanting to measure lung volume. If it's nutrition, you might want to measure weight loss. If it's stroke, you might want to measure blood pressure. Orthopedics, you might want to measure bone strength following surgery. The outcome is called your variable of interest. This is also called the dependent variable. The answer to that variable will depend upon each specific person. So add your outcome to your diagram. Predictor, outcome. What is that outcome? Lung volume, SBP, weight, etc. Then you need to get your predictor. So now that you have your outcome specified, what is your predictor and how do you pick the predictor? Choosing a predictor, this is the variable that you want to determine if it is related to your outcome. That is, does knowing this variable help you determine the outcome? So very simply, with a single variable, systolic blood pressure, for example, if a random person walked up to you on the street and said, "Guess my blood pressure," your best guess would be the mean of all possible blood pressures. If a person asked you what their lung volume was, the best guess would be the mean lung volume of all lung volumes. But sometimes knowing additional information about the people in your study or the observations gives you a better prediction. So does knowing someone's age give a better prediction of their lung volume? Does knowing their weight give a better prediction of the lung volume? Does knowing their smoking status give a better prediction of their lung volume? So our outcome here would be lung volume, and our predictors for these types of questions would be weight, age, and smoking status. So once you've chosen your predictor, you can add that to your question. So let's say it's lung volume as our outcome, and our predictors here were sex, age, and weight. Oftentimes you wonder, can some variables be both predictors and outcomes? And the short answer to that is yes. Obviously they cannot be both outcome and predictor, at the same time. But here are some examples. We've seen that defining the question is incredibly important, and determining whether a variable is an outcome or predictor can be tricky sometimes. You could be interested in predicting high blood pressure. In that case, the high blood pressure is the outcome. But you could be interested in using high blood pressure to predict if someone will have a stroke. In that case, high blood pressure is the predictor. You might be interested in predicting at what age someone would have a stroke, and in that case, age or the age of an event occurring is the outcome. You may be interested if older age are more likely to have a stroke, and in that case, age is the predictor. So you can see it really does depend upon the question. Once you get your question defined, you'll be able to allocate your predictors and your outcomes in the appropriate places. Just keep in mind that we don't generally try to predict sex or gender or race or someone's age in general. We can try to predict how old people will be or how many years it will be until an event happens, but in general, we see sex, age, race, gender as predictor variables or covariates. So once you have your outcome and your predictor, then you need to define the relationship. So again, what are the types of relationships and how do you add those to your question? We generally ask if there's a difference in the outcome by the predictor. By the predictor. Is mean lung volume different by race? Is the percent with low lung volume different by sex? The outcome can be continuous or categorical, and in this case, for those questions, the predictor will be categorical. Our predictors are categories of race or sex, with our outcome being lung volume. Correlation is another way that we look at relationships or association, is lower lung volume correlated with age, and both of those variables are continuous. So defining your variables, how those variables are collected, what the levels of those variables are, or if they are a number response is also critical to answering your question with data. So now add to your question the relationship. For example here, do men and women have different mean blood pressure? The predictor here is sex. The relationship is we are looking for a difference between them, and the outcome is blood pressure. It's incredibly important to remember when you are reporting statistical results to report who this will matter to. So not every study applies to every group of people. So add the population to your question. So you have your predictor, your outcome, the relationship you're looking to address, and who or in whom is this data going to be applicable to? People with MS, college students, U.S. residents, veterans. You can be very broad, U.S. residents, or you could be very specific, U.S. residents ages 45 to 60 with documented lung health diagnosis. So make sure that you understand where your data is coming from and whom the results will apply to. And that's how you begin to diagram a research question. It seems very simple, but can often be one of the hardest things to define in research. Once this is well defined, you'll be well on your way to determining your analysis type. So to do that for our next activity, considering the SBP weight data, for each variable, ask yourself, do you think this is a predictor, an outcome, or could it be both? Then write a question using the following variables. So you'll write 3 questions. A question about smoking history as a predictor and high SBP blood pressure as an outcome. Remember, define your predictor, your outcome, and the relationship in your question. Gender as a predictor with SBP value, so the numeric response is the outcome. And another question with weight as predictor and SBP value as an outcome. Identify the type of variable for each. So what type of variable do you have for your predictor and your outcome? Are there levels to the outcome, or are there units associated with a continuous outcome? Up next, we'll learn how to take these questions and translate them into a statistical analysis for bivariate analysis.